Welcome sa part 9 ng ating Thermodynamics lecture series. Ayos pa ba kayo? Yes, sir! Alright, mag-ingay! Woo! Alright, okay. O, kayo mga tropa. Ayos pa ba kayo mga tropa, ha? Yan. Ayos ba? Ayos ba? Meow! Shh! Okay, ayan. Okay. So, chill lang kayo, ha? Ikaw, chill ka lang, ha? Okay, ikaw, chill ka lang din, ha? Alright. Okay, so start na tayo ng ating part 9. And here we have the last two thermodynamic process, which is adiabatic or isentropic process, and then we have our polytropic process. So, sige, game. Una, the PV and T relations. So, this time, tatlo po yung ating makikitang formula. Okay. So, kasi this time, K, makikita na natin yung K dito. Sabi dito, P1V1K is equal to P2V2K. Ayan. So, ibig sabihin, sa ating isentropic process, ano po bang meron? PV raised to K is equal to constant. Ayan. Kaya nga lang, sir, meron pa kaming tatandaan na dalawa pang additional formula. So, medyo, sir, paano yan? Ang haba niyan eh. Dami na naman namin sasauluhin. So, hindi naman natin kailangang sauluhin actually, di ba? No, kasi ito pong dalawang to ay derive lang din. No. So, paano yun, sir? Derive lang. Oo, ganun pa rin naman, bigyan ko lang kayo ng idea kung paano siya makukuha. Pero still, no, ang kailangan nyo lang tandaan ay syempre yung unang formula natin, P1V1K is equal to P2V2 raised to K. Yan. So, ito yan, no? P1V1 raised to K equals P2V2 raised to K. And then, ang gagawin lang natin, gagamitin natin yung ating combined gas law. Anong yung combined gas law? We have P1V1 all over T1 equals P2V2 all over T2. Yan! Yan lang pala, sir. Okay. So, halimbawa, ito kasi sa una natin, pressure and volume yung given. Ito sa pangalawa, temperature and volume. So, ang gagawin mo lang, tatagtagin mo yung P1 at saka P2. Kukunin mo yung ratio ng P1 and P2. So, with that, pag dito sa ating combined gas law, so we have P1 over P2 equals, so, binaba ko yung P2, we have T1 V2 all over B1 T2 or T2 V1. Yan. So, ang idea lang nito is kukunin ko lang yung P1 over P2 ng ating first equation. So, P1 over P2. So, we have V2 over V1 raised to K. And then, equate ko lang dito sa ating nakuhang equation dito. Yan. Okay? Dito lang natin i-equate. And ano mangyayari? Makukuha na natin itong second formula. Yan. Same goes with this third formula. No, actually, hindi naman kailangang i-form ng ganito eh. Basta magawa lang natin, ma-equate lang natin yung P1 over P2 doon sa ating, yan, dito. No. So, halimbawa, ito yung P1 over P2, kukunin natin yung P1 over P2 ng first equation, ha. We have P1 over P2 equals, V2 over V1 raised to K. Yan. So, ito, at saka ito, equate mo lang. So, itong dalawang ito na po yun. Yung second formula. Same goes with the third nga, ganun lang din po yung gagawin. So, mamaya, try nating magamit sa ating, problem solving. Pero para sa akin, hindi mo na kailangan sa ulo itong dalawang to. Yan. Ang kailangan mo, alam mo yung first equation at saka alam mo yung combined gas law. So, kayang-kaya na po. Ito kasi masyadong bulky sa uluhin, kaya I don't recommend this to be memorized. No. Next, we have PV and TS diagram. Ito po yung nangyayari habang tumataas yung volume, bumababa yung pressure. And then, in terms naman ng TS, we have a constant entropy. Kaya nga lang, sabi dito, kahit bumababa yung temperature, constant pa rin yung entropy. Okay? So, that's why, ano mabubuong area under the curve nito? Meron bang area under the curve? Ano lang naman siya, vertical line? Wala po. Okay? So, may yan, may significance po yan. No? So, malalaman natin. Bakit, ano bang meron kay asentropic? Wala po kasi siyang energy. Diba? Wala siyang change in, wala siyang change in entropy. Yun pala. Kaya po, ganyan yung ating graph. And then, for the non-flow work, so, non-flow work is equal to PDV, ganun pa rin. Kaya nga lang, dito ang P natin ay C over V raised to K. Yan. And this time, ito na po yung formula natin. Kapag nag-integrate tayo ng mano-mano, we have P2V2 minus P1V1 all over 1 minus K. Or yung nasa taas, pinaltan mo lang kasi yan ay delta PV. Delta PV yan. So, pinalitan mo lang ng MR delta T. Still, this is, the ideal gas law. No? So, ganun lang po. It's either P2V2 minus P1V1 all over 1 minus K o kaya MR delta T over 1 minus K. That is the non-flow work. Okay? Next. Steady flow work. Ganun pa rin. Negative VdP. Yan. Pero kung mapapansin nyo, ano lang meron, sir? Nadagdagan lang ng K sa numerator. And yun lang po talaga yung kailangan yung tandaan. Kaya pala yung ating isang formula dito is the steady flow work is equal to K times the non-flow work. Ayan, nakamultiply lang yung K. Okay. And then we have the internal energy, change in internal energy, MC delta T pa rin po. Okay. Or equal siya sa negative non-flow work. Yan. Ano ba yung non-flow work natin? Ito. Yan. So, kaya nga lang, negative po yung ating change in internal energy. But still, ito pa rin yan, MC delta T, MCV delta T. Kagaya ni change in enthalpy, MCP delta T. Same pa rin. Heat transferred. So, ang ating heat transferred daw ay 0. Okay. So, ito nga kasi yung yung definition ni adiabatic process. There is no heat transferred. No, to or from the system. Kaya 0 yung ating heat. And kung 0 yan, ayun, doon pala nakuha yun. Yung delta U is equal to negative non-flow work. Ayan. Kaya pala bigla tayo nagkameron dito. Yan. And last, change in entropy is matic 0 siya. Kaya nga po siya isentropic. Okay? Alright. Okay. So, dapat po, kabisado natin yung mga formula sa atin. No? Kaya nga lang, magkaka-connect po yan. Kaya po mahalaga na kapag tayo ay nagmamaster ng formula, kailangan po, kabisado natin yung bawat isa. No? Alam natin yung mga pagkakaparehas sila at saka yung mga differences nila. Okay, 29. Air having an initial pressure of 6,516 kilopascals and an initial volume of 0.113 cubic meter and final volume of 0.057 cubic meter. Calculate the pressure at the end of compression. Alright, so paano ba yung gagawin natin dito? So, ang given lang po sa atin is the pressure. And then, meron tayong V1 and V2. So, meron tayong isang pressure at dalawang volume. And this time, hinahanap si pressure at the end of compression. So, most of the time, kapag compression pinag-uusapan, pupunta tayo sa isentropic. No? Ayan. So, okay, game. So, ang gagamitin natin is the first formula. We have P1, V1 raised to K equals P2, V2 raised to K. The problem is, hindi natin binigay, hindi binigay sa problem yung K. Pero dapat, pag air po, dapat kabisado natin yung constant K, the gas ratio. Ano po ba dapat ang gas ratio kapag air? We have K is equal to 1.4. Ayan. And kapag alam natin si K equals 1.4, madali na pong isolve yung ating problem. Okay, so game. So we have P1, 6516 kilopascals. V1, 0.113 cubic meter. Raised to 1.4 equals P2 times 0.057 cubic meter raised to 1.4. So, dito hanapin natin si P2. Pwede na tayo mag-diretso sa calculator natin. Let's go! Game. So, we have 6516 kilo pascals times 0.113 raised to 1.4 equals. Okay. So, hinahanap si P2 times 0.057 raised to 1.4. Game. Ship solved! The correct answer is yan. We have, isin na natin. We have 16985 kilo pascals. So, meron ba tayo dyan? Meron ba tayo dyan? Of course, sir. Letter B. Ayan. Medyo nakakaliyo lang yung mga choices. Pero yun, 16985 kilo pascals. Alright! So, proceed tayo sa number 30. How much work is necessary to compress air in an insulated cylinder from 0.20 cubic meter to 0.01 cubic meter? Use T1 equals 20 degrees Celsius and P1 equals 100 kilopascals. So, ito po yung pag nakita nyo, matic isentropic to. Alin po yun, sir? Ito. Insulated. So, since kapag isentropic, there is no heat transferred to the system. There is no heat transferred papunta sa system or paalis sa system. Therefore, we can call that system insulated. So, kapag nakita natin yung keyword na insulated, matic yan? Isentropic. Okay? Ayan. So, game. Ano po bang given? Dalawang volume. Tapos, meron tayong T1 at saka P1. Ang tanong, work. So, yun. 'Di ba dalawa naman yung pagpipilian natin sa work. So, sabi natin, non-flow work lagi pag hindi binigay. Hindi sinabi kung steady. So, non-flow work is equal to P2V2 minus P1V1 all over K minus 1. K minus 1 ba? O 1 minus K? 1 minus K. O kaya naman ay MR delta T. T2 minus T1. 1 minus K. And with that, alin po ba yung gagamitin natin? So, inspection tayo. Meron tayong volume. May dalawang volume. Tapos, meron tayong temperature tsaka pressure. Okay. So, again, this is air. Alam natin yung K niya ay 1.4. So, wala tayong problema sa K. Problema lang natin ay yung mga kulang na given. So, kung mapapansin nyo dito, meron tayong P1, T1, at saka V1. Ang kailangan nating hanapin ay meron tayong dalawang V1, meron tayong P1, P2. Kailangan nating hanapin si P2. And with that, para mahanap natin si P2, gagamitin muna ulit natin yung ating first formula ng PV and T relationship, which is P1 V1 raised to K equals P2 V2 raised to K. Game. We have P1 100 kilopascals. V1, 0.20 raised to 1.4 equals P2. Ano yung P2? Yun po yung hinahanap natin. Times 0.01. Uy! Tama ba? V1 natin is from, okay, tama. V2. 0.01, 1.4. Makukuha natin si P2. Okay, game. Kunin natin si P2 100 kilopascals times 0.20 raised to 1.4 equals over 0.01 raised to 1.4 equals. So we have P2 equals 6.63 megapascals. And yan po yung gagamitin natin sa ating formula. Ayan. Okay, so dito na natin lagay, ano. So we have P2V2 6.63 megapascals times V2 is 0.01 minus P1 100 kilopascals times V2 V1 0.20 all over 1 minus 1.4. So pag ginawa natin yan, sige nga, diretso na natin sa ating calculator. We have times 0.01 minus 100 kilopascals times 0.20 equals all over 1 minus 1.4. So the answer is negative 115.72 kilojoules. Alright. So negative 115.72 kilojoule. So, meron ba tayo dyan? Meron ba tayo dyan? Of course, sir. Letter A. Okay. So, negative po yung nakuha natin. Ano? So, ibig sabihin, negative po yung work. Ano? Pag sinabing negative work, it is the work done to the system. Alright. Pag positive, work done by the system. Okay. So, next. Ayan. So, the last process na meron tayo, the polytropic process. So, ito po ay halos parehas lang din po ng ating isentropic process. Pinaltan lang po natin yung K ng N. Kung mapapansin natin. Okay. Ayan. So, same with PV and TS diagram. Non-flow work. Instead of 1 minus K, 1 minus N yung makikita natin. And then we have the steady flow work. Yan. So, ganun pa rin, ang multiplier naman natin sa numerator IN instead of K. Then, change in internal energy, same. Change in enthalpy, same lang din. And then, we have the heat transferred. Ito naman po yung pinagkaiba nila. So, this time, ang heat transferred natin is, MCN delta T. Uy, may CN. So, ano po yung CN? Ito po. CV times K minus N all over 1 minus N. Okay. So, tatandaan nyo to. Ito yung bagong formula kay polytropic process. Ang pinagkaiba kasi sa ating adiabatic, isentropic, ang ating heat transfer ay 0. Okay. And then, we have change in entropy. We have MCN ln T2 over T1. So, ito po yung original formula ng ating entropy na nakabase, ang nababago lang is yung ating C. Okay. So, ito lang po talaga ang ang kailangan tandaan na formula sa polytropic. Okay, game. Let's do this. 31. During the polytropic process of an ideal gas, the state changes from 138 kilopascals and 5 degrees Celsius to 827 kilopascals and 171 degrees Celsius. Find the value of N. Alright, so this time hinahanap si value ng N. So, tingnan muna natin yung ating mga given. We have temperature 1, temperature 2, we have P1, and P2. Uy, tapos hinahanap si value ng N. So, dito, madali lang. We will just use the formula for PV and T relations. Kaya nga lang, ang alam natin is the first formula, yung pressure at saka yung volume. Oo. So, gawin natin, i-derive natin yung pressure at saka temperature. So, doon muna tayo sa pressure and volume. Yan. Tapos, alam natin, ang ating combined gas law, P1 V1 all over T1 equals P2 V2 all over T2. Okay. So, since ating kailangan is P1 and T1, say goodbye muna tayo sa ating volume dito sa first. No. So, we have, extract natin, V1 over V2 raised to N equals P2 over P1. Ayan. So, ang kailangan natin matagtag is yung V1 over V2. Di dito natin kukunin yun, no? So, we have V1 all over V2 equals P2T all over PT2. Ayan. So, itong P2T over PT2 ay ipapasok natin dito. Ayan. Yan. So, that, ang ating formula na makukuha ay P2 T1 all over P1 T2 raised to N equals P2 over P1. And that's what I'm saying. Na hindi na natin kailangan sauluhin yung form na nandun sa binigay kong formula. We just did the formula for the first P1 V1 raised to N equals P2 V2 raised to N at saka yung ating combined gas law. And tada! Yan na po ang ating formula. So, game. Pasok lang natin yung mga kailangan. P1 is 138. Okay. Bura. So, game. So, we have P2. P2 is 827 kilopascals. T1. So, T1 natin is what? 5 degrees Celsius. Pero, huwag kakalimutan na, dapat naka-Kelvin. Next, we have P1, 138. Kilopascals times 171 plus 273 raised to N. Yan yung hinahanap. Equals P2 over P1. 827 kilopascals all over 138 kilopascals. And then, makukuha na natin si value ng N kapag nag-shift solve tayo. So, game. Tiranin na natin to. Let's go! We have 827 times 5 plus 273, 278. Then, 138 times, compute ko to. Yan. So, naka-raise to N tayo, di ba? Oo. So, raise to X. equals ratio of 827 at saka 138. Ship solved equals. So, ang nakuha nating value is 1.35. Okay, 1.35. Oh, meron ba tayo dyan? Yes, sir. Letter B. Easy. Alright. So, ganun lang po, ano. Again, we don't need to memorize the second and the third formula in the PV and T relationship of a polytropic and isentropic processes. Okay, so last question ng ating part 9 of thermodynamic lecture series. Game! Let's do this. One gas at 1 atmosphere pressure originally occupies a volume of 20 cubic feet. The gas is polytropically compressed with N equals 1.15 until the pressure is 48.51 psia. What work is required for this compression? Okay, so this time, no, sabi nga natin meron tayong dalawang formula ng ating non-flow work. Ano nga ulit yun, sir? Recall lang tayo. We have P2V2 minus P1V1 all over 1 minus N. Then we have MR delta T, T2 minus T1 all over 1 minus N. Okay, so dapat alam natin kung anong gagamitin natin dito. Game. Meron tayo ditong 1 atmosphere. That's the first pressure. Volume. So we have V1. Okay, so P1 V1. Meron tayong N. Pressure is 48.51. Alright, so meron tayo ditong P2. So P1 at P2 present. So malamang-lamang first equation yung ating gagamitin. Tapos may V1 pa. So V2 na lang yung kulang. So alisin natin to. Since walang V2, hanapin muna natin siya. Okay? So first equation ng ating PV and T relationship. We have P1V1 raised to N equals P2V2 raised to N. And then we have here 1 atmosphere. So 1 atmosphere, convert na natin siya sa ano? Sa 14.7 psi. V1, 20 cubic feet raised to 1.15. P2, we have 48.51 psia. Then we have V2 raised to 1.15. So, compute natin si V2. Game! We have 14.7 times 20 raised to 1.15 equals 48.51 times x raised to 1.15. Ship solve, we have equals 7.08 cubic feet. No? Pero since hindi pa yun yung final answer, mag-store muna tayo. Ship store A. Next, gamitin natin sa ating formula ng non-flow work. So we have P2V2. P2 is 48.51. Pero kung mapapansin natin, ang ating unit ng mga choices ay naka-foot pound. So, kung ito'y naka-square inch, edi convert muna natin. So, we have 12 inches in 1 feet square para makancel yung inch squared. Then, we have V2. Ano yung V2 natin? 7.08. Minus P1. Baba muna natin. Minus P1. P1 is what? 1 atmosphere or 14.7. Ganun din. Times 12 inch over 1 feet. square times 20 all over 1 minus 1.15. Okay, so pindutin na natin sa calcu game. So we have 48. Okay, isi natin. 48.51 times 144 times 7.08, which is yung ating nakuha kanina, minus 14.7 times 144 times 20 all over 1 minus 1.15 equals negative 47,560. So, negative 47,560. Meron ba tayo dyan? Negative 47,560. Sir, wala po. Pero pinakamalapit yung ating kukuning sagot dyan. Alin yung pinakamalapit? 47,560. So, parang si letter B yung pinakamalapit, no? 13 lang yung difference. Alright, so tama, letter B. Okay, so that's all for our thermodynamic processes. And to summarize those process na pinag-aaralan natin, ayan. So the general equation for thermodynamic curves is the PV raised to n equals C. So yan po yung ating polytropic, no? Yan. Wherein si n daw kapag 0, siya ay isobaric process. So, V to the 0 is equal to 1. Mangyayari, P equals C. Constant pressure. Then, isothermal, N is equal to 1. Magiging PV equals C. The equation of isothermal process, PV and T relationship. Kapag naman isentropic, PV raised to K equals C. And last, kapag daw isothermal, isometric, PV raised to infinity is equal to constant. So, V raised to infinity, constant volume, isometric. Ayan. So, that's all for our part 9 ng ating thermodynamics lecture. And see you sa last part ng ating lecture series. So, God bless, future engineers! Bam!